Hello everyone, I'm David Webster. I'm an engineer at Alfresco, and for the last 3.5 years I've been that. I taught myself how to code. And one of the things you do when you're teaching yourself how to code is you get quite good at working out what to do when things go wrong. And that's what debugging is. It's taking something that should work but doesn't, finding out why it doesn't work and making it work. And so I think that's quite an exciting thing to do, right? Because by its very nature, it's a learning process. And learning's cool, right? So now when I'm not staring at a screen and working on code, I go out and I walk up mountains and I volunteer with a search and rescue team. Right, that's pretty exciting, but I find debugging codes very exciting too. I like to think of it a little bit like it's a murder mystery that's happened inside the browser, and the clues are all wrapped up in JavaScript, just waiting for you to find them. So my plan for this session is to give you some tips and techniques to help you find those. So we're going to start off with some general debug principles, and then we'll take a look at some tools that we can use as client-side developers to help us with our debugging. And along the way, we'll look at some development practices that can help with debugging as well. So this is a photo of my house. Recently bought a house that needed quite a bit of development work doing to it. And I'd never done anything like that before. It was a huge learning curve for me. And so all the DIY and house renovation was brand new to me. But something I didn't need to learn was how to solve problems. Because the problem-solving techniques you use for debugging code, they can also be used to debug a heating system or solve an electrical fault. So it's the process that you use to take a look at those errors that's really fundamental there. Some of the processes I'm going to talk about may seem a little simple, but the simple processes you use are the best. And they're the ones that if you follow them and stick with them, regardless of how complex the code gets and the debugging is, just follow the process and it will help show you the right way through. So there are two distinct phases I think of in bug fixing. Firstly, you've got to locate the issue, and then you've got to fix it. It's as easy as that, if only it was. Sometimes locating the issue can be the biggest mission of all, and that's what we're going to spend time on today, is just kind of where to find that. Sometimes you get an error in your JavaScript console that tells you the file name and the line number. Sometimes that's right, sometimes it's not. But either way, it's a clue that's quite hard to ignore. But if we haven't got anything like that, you've got to start in a different place. And here's my general approach to doing that. So to start with, you've got to get an overview of the system. You've got to work out how the data or the electricity or the water or whatever you're dealing with, how that flows through the system, where the key points that data gets interacted with. And then, so once you've got a good overview of how it works, you then need to break that system down into components. And I'll discuss in a moment some good points to break up the system. And then, so once you've got those breakpoints, the components separated, you isolate them, and you've got to test the inputs and the outputs and see what's going on. Now, does that isolating and testing sound a bit like unit tests? Good, it should do, because it's the same basic premise. And I know client-side developers have historically been quite lax on unit testing. And that was fine back when client-side developing was about markup and styles. But we've progressed past that now, and so there's really no excuse to not be using unit tests. And they're part of the good development practices that, if they're being used, will massively help your ability to debug your code. So, okay, we're going to turn Clue Hunter now and discuss a couple of good places to look for clues. So start first with our XHR calls. So these are the AJAX calls that are bread and butter of any major web app, including Share. So generally, web apps do things in response to receiving data from the server. So taking a look at that data and the request that triggers it is a very good place to start. So whether it comes from a web script call on the web tier or from the client-side code itself, they're quite an obvious and useful place to break up the components. And I'd say the majority of the issues on the current project I'm working on can be traced back through network requests. And I don't know about you guys, but if you work on discipline-specific teams like we do within Alfresco, good reason to look at XHR calls first is that if the UI is having issues with data that's being sent from the server, it's often someone else's problem to fix it. So they're a good place to start. Next up, we've got events. This is something that Share's starting to use pub/sub events a lot more. It's something that was always there, but with the changes in 4.2 and the new AMD-style widget definition, something that's become a much more regimented development practice for us. So that's the publication of and the subscription to events. So good places to set breakpoints around that are where the event gets triggered, and then within the listener, the handler that responds to that event. Set breakpoints there, and you can check the flow of data, check what's happening, and also the timing of the events as well. Next on my list is DOM elements. If your app does any DOM manipulation, and I've not seen any web app that doesn't, checking the selectors you use is quite important. So libraries like jQuery can be quite hard to track down issues with selectors because they fail silently. So if you've got methods that are chained up coming from a selector, and that selector doesn't match anything, you don't get any real feedback. So you need to make sure that, and just actually test what's coming through as a result of that selector. Now, something we often do is use class names as selectors. And that's fine, there's no problem with that. But what I would suggest is that those class names should be prefixed with JavaScript or something like that, just so you know that that's being used to handle JavaScript behavior. And that way you're separating the concerns between the JavaScript and the CSS, and you can refactor either without affecting the other. So keep your selectors separate. And then the last place I'd say is undefined is undefined. That's a very common error I get, and that's we really shouldn't be getting that. It's the equivalent of a Java null pointer exception, and our code should be catching them. So yeah, if you write your code defensively, check your methods input and returns, we shouldn't see that. So next up, fixing the issue. I won't dwell too much on this because I want to get on to some debug tools and other things. But in order to fix the issue, you need to know what that code's currently doing. So once you've found where the code is that's causing the issue, you need to know what it's currently doing. And then in order to fix it, you need to know what it should be doing. Okay, so a couple of development tips I'll quickly go through. Because as much fun as debugging is, it doesn't compare with that smug feeling that you get when you write code that's perfect the first time around. Or so I've been told anyway. So enjoying debugging code's not a good excuse to write code that isn't robust. So first on the list of things to do to get it right first time is validate method inputs and returns. So if you're expecting a string, check you've got a string. Should it be blank? So if you code defensively, And that's especially true if you're writing code that other people will build upon. So you're writing an API or something. That's pretty key there. If you keep your code simple, and it's a lot easier to follow, I find often with complex code, there's only one point in time where that code block is fully understood, and that's when it's written. So that's the time to comment that code when you're actually writing it. Even if it's just for your future self, in a year's time when you're debugging code in that, you're debugging that, and it's 4 o'clock on a Friday and you just want to get it done, then you'll be thankful that you've added the comments. So modularity, and this is something we're really pushing in Share at the moment. If your code's modular, it's easier to test. The places to separate it to do the debugging are already well defined. And so, yeah, it just makes good sense to do that. And also, if your modules are reusable, then you've got less code for bugs to occur in anyway. And throwing errors, something I think a lot of JavaScript developers overlook. But if you've checked a variable and it's not as you expect it to be, throw an error. That's what should happen, and it makes debugging easier if you get an error that tells you what's gone wrong. So predict and catch common response errors. So if you're expecting an error in some situations, then handle that. So for example, within Share, some of our Ajax calls could return a 401 response, which is unauthenticated. So that's something that we catch, and we show the login box, and we handle it that way. And that means that we've improved the experience for the user, and we're also not having to debug why things don't work in certain circumstances, because we've caught that and we're handling that common error. Something else I think is very important is code linting and IDE auto-completion and things like that. If you've got an IDE that can spot possible errors and alert you to those before that code hits the server, then that massively increases your productivity. And I say can detect possible errors because not all, the editors just aren't smart enough to understand all code, and there will be some that, some things you can ignore and some things they won't catch, but it's a good start. We've already mentioned unit tests today, so they're a good idea, as are functional tests. So those are the tips I've got for maximizing your chances of not having to debug. But we will all have to do debug at some point. It's just one of those facts of life as development. So I'm going to take a look at a few tools that I use, and hopefully you can take them away and use them as well. Hands up if anyone knows what this picture has to do with debugging code. No? Okay. It's a technique I was introduced to, I think at the start of this year, and it's a rubber duck. It's a fab method of debugging code. And I know we've all been there when we've got some tough code to try and debug, and we're going through. We've looked at it, we studied the code, we think we understand what's happening. We know where the data's flowing, what it's doing. We've gone through line by line, and we think this code should work, but can't understand why it doesn't. So we call over a colleague. We start talking them through the code, explaining to them how we think it works. And then suddenly, without any input from the colleague, we understand what we missed previously and why the code doesn't work as expected. Now, in this situation, that rubber duck can be as effective as a colleague. So if you get a conceptual rubber duck on your desk, you can talk through the code, and that can save a lot of time, and it's quite a useful technique. Obviously, it's easier if you're working on your own and you're not talking to yourself in the office, but each to their own. Okay, so that's a useful technique. And now I'm going to try something I've not done before live. So I've got a couple of videos of pre-recorded demos I've done. So hopefully they're going to work as I want them to. But before we look at those, actually, I think that as client-side developers, we're very lucky because we've never had tools that are as good as they are now. And I remember when Firebug was released, and that revolutionized the way I developed code, and things have just continued to get better since then. And so a couple of other quick tips. I'd suggest with your web browsers, we all develop using web browsers, so I'd suggest separating out your everyday browsing and your development browser. So use one for regular browsing and one for development, and just keep them separate. And secondly, something that I don't see people do as commonly as I'd expect it to be done, but turn off the cache in the browser you're developing in. I know we've all been there. We've modified some code. We don't see it on the server we expect to. We're trying to work out why, and it turns out it's a cache issue. So turn off the cache on your development browser. And if you're getting fresh content every time you reload the page, that's just one less issue to have to think about when you're debugging. You still need to turn the cache on occasionally to test how your app performs with the cache on, but you don't need to do that all the time. So this is, hopefully you can all read that. This is a video of my Chrome instance. We're looking at, is the video playing? Hopefully the video is playing. And so we're looking at an instance of, we're looking at the instance of Alfresco in the cloud. So we're debugging a live production server. And let's get that video playing. There we go. So yeah, we're debugging a live instance of Alfresco in the cloud. And important thing to remember about Chrome DevTools is they're not open by default. Yeah, it is playing. That's just a bit of an intro. Okay. So yeah, important things to note about Chrome DevTools is that they don't do anything if they're not open. So once you've opened them up, you need to reload the page, or you need to have them open before the page reloads, or before the page loads. Sorry, it's not, that video is not playing. Here we go. That's a bit better. Sorry about that. So as I was saying, this is Alfresco in the cloud. We're going to debug a live production instance. So that's where we're looking at. This is Chrome, my development instance of Chrome. And we're looking at the Alfresco Summit speaker resources site. And so if you've done any sessions here, this is where you should have uploaded your stuff to. So this is the network view. I was saying about that. Because it wasn't open when the page loaded, it hasn't picked up anything. So we're just going to go ahead and reload the page. And then this network tab will show us all the requests that are made as the page loads and onwards throughout the life of the page. So in here you can see all the URLs that are being called. and you get a lot of information about that. But if we have a look at the Elements tab, so you can see in here, this is the view of the DOM. So remember when you used to have to right-click on the page and go into View Source and see the code that way? That was a static view of the DOM. But this gets updated every time we do any DOM manipulation. So it shows the actual live, the live code that's being rendered on the page, and you can modify the code here. You can add new elements. You can add classes, remove classes, do all those sorts of cool things that a few years ago we just didn't have that ability to do. And also in the Elements tab over on the right-hand side, you've got this Styles panel, and that's where you'll be working if you're doing any CSS debugging. I use it when I'm developing new widgets, writing CSS for the first time, but it's equally useful for debugging CSS. So this is the JavaScript console. And there's a lot going on here, but basically it gives you it's a JavaScript interpreter. You can type whatever you want to on the command line down here, run that in your browser, and you've also got access to all the local variables, all that sort of useful stuff there, and you can investigate objects, drill down into them. It's fantastically useful. A couple of options worth mentioning. Right-click, you can clear the console, get rid of all the stuff there. And two settings I like to have enabled are log XHR requests, so that every time AJAX call is made, that gets printed out into the console. And secondly, preserve log upon navigation. That's really useful if your page, you have a navigation event, and so your page goes somewhere else as a result of a response from the server. So often we'll send a call in. If that call is successful, we'll send the user onto a different page. But the problem with that is that often it's quite hard to then debug the response back, because the first thing that happens when that response comes back is you end up going to a different page. If you've got this option enabled, then that log gets preserved, and you can still have a look at that. So next up, we've got the Sources tab. This is where you're going to spend a lot of your time with doing the JavaScript debugging. So you've got access to open all of the JavaScript and CSS files. So what we'll do here is we'll hit Command-O, we'll open Alfresco.js. That's the core Alfresco library. And the first thing you'll notice, having opened that file, is that it's minified. That's because we're running against a production server. So that makes it quite tricky to debug. But luckily, the guys at Google thought about that, and so they've put in a pretty print option. So if we go click on the curly braces down on the left-hand side of the screen, that instantly makes the file usable for debug purposes. So what we'll do here is we'll go through, we'll search for a method, just a random one to debug. We'll use Alfresco util message, just because that's one I was speaking about yesterday. So here we can see we found 50 matches, and so that's how many times that method is used. Well, it's used at least that many times. And so if we add a space onto the end of that search string, we get to the function definition, which is where we can start doing the debug. So you'll see here that although Alfresco util message hasn't been altered by the minification process, the parameters passed to the function, here A and B, they have been. So the useful parameter names we put in, they're just not there anymore. And that's because any objects you call using the dot notation in JavaScript, they can't be minified by the minifier because they might be referenced elsewhere. So that's something worth bearing in mind when you're minifying your files. And a pattern we've got within Share is we often take that util method and assign it to a local variable, in this case A, and then every time that gets used, the minifier is able to optimize that. So that's a good space-saving technique. That probably saves us quite a few bytes across the whole of the share code. But what we're going to do now is we want to find out what A and B are. So we'll set a breakpoint just by clicking on the file number, and then we'll reload the page. And what that does is that, because we've got the breakpoint there, that will pause the JavaScript, the execution of that JavaScript where it hits that breakpoint. So here we are inside the paused JavaScript. We've got full access to all of the variables in the closure. We can run functions on the command line. So here, if we start inspecting it and we take a look at A, we can see that that's our message key. When we take a look at B, we can see that's undefined. So B didn't get passed in. What we can also do here is follow through and have a look at the code flow to work out what's going to happen next after this debug point's been reached. So we can take a look at this if statement, for instance, copy and paste that onto the console. We can see it's not false. A is a string. So where else are we going to exit in this method? We've got a return function. That's quite an obvious exit point. So let's hit play, move on to that exit point. And then you can hover over the variables or the local variables, and you can see that in this case we've got the days of the week. So this function returns days of the week. But where does it return it to? On the right-hand side of the screen, we've got this call stack. So Alfresco util message is our current function, and we can see that that was called by an anonymous function. So let's click on that, step into it. That doesn't change the fact that the code is paused, but it does enable us to see where this function was called from. So in this case, Alfresco util message returns to that variable. That's fine. So we understand what happens within this function. So now we've got two breakpoints in a function that we know is used quite regularly. So what we can do is we can edit this breakpoint, and we can turn it into a conditional breakpoint. So in this case, we're going to only make it active. So it's only going to stop the code if there are 3 arguments that are passed in. So arguments.length double equals 3. So if that's true, then that breakpoint will trigger. Otherwise, it'll just ignore it. So that's that breakpoint handled. We'll save that. It's gone orange, so we know that that's a conditional breakpoint. We'll go down, and we've still got that other breakpoint, the one we're currently paused at. So we can go over onto the right. We find the breakpoints list, and what we can do is we can uncheck that. So that means that Chrome kind of stores a reference to where it is, and we can use it as a bookmark almost to jump around the code, but it won't actually affect how the code flow happens. So we'll play that. We'll come through to this breakpoint's been hit again, and so that means that we've hopefully got 3 arguments. We can inspect the arguments method, have a look. Okay, so we've got our 3 arguments there in that arguments array. Now, something that's worth bearing in mind is anything that's typed on in the console here doesn't trigger any breakpoints. So what we can do is we can call the Alfresco util message method. We can pass in our A variable, and we can see, okay, so that's what the response would be. I know in this case that the token there will get replaced with the 3rd argument. So this method will return 2 months ago. So that's our return. But again, where does that go to? Over on the right-hand side, we've got the call stack. It's a little more interesting this time. I'll just wait for the video to catch up a bit. Here we go. So Alfresco util message was called by a function called n. That'll be a minified function name. So we can see here we have Alfresco util message. That's called assigned to local variable m, and we've got that m.apply within that function there. So that's where that gets called. And if we step up the call stack again, we can see that this is where the actual invocation happens, and we can see that that's where the variables get passed in. So we can check the inputs to our method there, and they match. And we can also inspect and find out why we ended up in this particular code path. So that's a really useful thing to be able to do, is to look back and find out, okay, so like a bit of archaeology there, we can dig up and find out what happened. So we've gone up the call stack again. So we see we've got a DOM query here. So we can have a look at, we can paste this into the command line, and we can take a look and see what selectors were matched there. So if we right-click on that, we reveal it in the elements panel, and then so we can find the actual element we're using. We can't see it on the screen at the moment, so what we can do is we can scroll that into view by right-clicking on it, and we can see, okay, so that's an ISO 8601 date, so that's going to be replaced by this relative date that's being returned from our message function. So if we go back to the message function, we hit play, we get past that point, and we can see exactly where that 2 months ago has been, was rendered from. So that's just a pretty quick kind of whirlwind tour of debugging Share within Chrome. And so that's that tool. The next tool I'm going to talk about is, I think it was this take that actually worked. So next tool I'm going to talk about is a tool I found out about 6 months ago called Burp Suite. It's a fantastic set of tools. I've not had a chance to delve into everything it does, but what I do think is really useful is the proxy, the intercepting proxy that it's got. So with the proxy server, you've got the ability for a proxy server to sit in the middle between the client and the server. So all the requests from the client go through the proxy server and onto the actual server, and then the responses from the server come back through the proxy to the client, and that gives that proxy a huge amount of visibility on those requests and huge amount of ability to control and manipulate those requests as we see fit. So we come into Burp Suite here. I'm using the free edition just because that contains all the features I need. It's a Java application, and what we do is we set up a proxy listener. So here you can see I've got a listener listening on that port on the localhost loopback interface. So if we come into Chrome, and then using a plugin called Foxy Proxy, and to enable a proxy server. So all URLs now go through Burp. So we can have a look at the config for that. See we're sending that to the same port that we set Burp up to listen on. And now we can go back to, I'm actually debugging a local Share instance here. So we reload this instance of Share, and we can then come into Burp Suite, and we can see, just as we did in the network tab in Chrome, all the requests coming through. Now you can see they're coming through quite slowly. That's because there's a single Java process that has to handle all those requests. So using Burp Suite does slow things down a bit, but it gives us fantastic visibility on that, and you can see the requests. You can see that, for instance, this is a get to the Share tag service with those parameters, and we can see the response is, in this case, there aren't any tags. So that's the request and the response we can see. And that's our Share page, that all the requests to build up that page went through Burp Suite. So I think the most exciting part of Burp Suite is the ability to intercept the requests. So rather than just forward them on automatically, that intercepts the request and gives us a chance to do stuff with them. So some of the options we've got around intercepting that, we can set up all sorts of filters. So we can say that, okay, there's only a certain type of request we want to listen to. And we've got the option of intercepting the responses as well as the requests. And this is kind of what I'm really interested in, is intercepting those responses. So we've got that set up. And something Burp Suite does, you can see the option there, is it updates the content length header when we change any code. So what we'll do here is we'll just trigger a small change to the page. We'll change the sort order on the document list, and it's filtered on the server side. So we make a request to the server to do that. So you see here in the proxy intercept tab, we've got a request that it's intercepted to the preference service for our admin user. It's saving the sort field. That's fine. We can forward that on. We don't need to do anything with that. And see, we called the response as well, so that's just a standard 200 response. That's fine. Forward that to the client. Here's the GET request to the document library data web scripts. Here's the filter parameters. So we can modify these now. So instead of filtering on CM title, we're going to make quite a basic change, but we're actually now going to filter on content.size. So this is us changing the data on the request. We forward on that modified request. We get the response back. We forward that response onto the client. And then we have a look here. And we can see that even though it was the title that we requested to sort by, because we modified that request on the proxy server, the data here is actually sorted by content size. And so that's really useful in enabling us to play around with parameters without having to actually modify our code. So we can go in and we can update the requests and see what happens in all those different cases. But I think the real power in that is what I'm going to show now, and that's modifying the response that we get back from the server. So let's filter this by name. So we come here, we've got this is the preference service call. That's great. So we can forward those on unmodified. Here we've also got a second preference service call to save the sort order. That's fine, we'll forward that on. This is the request we modified last time to the document library data web scripts. We'll leave that as is this time. CM name's fine. Forward that on. So response from the admin preference service. That's because the requests happened in parallel. So we had 2 requests and then 2 responses. This is the response we're interested in. That's the response from the repo that gives us all of the data. So this is unformatted JSON. It's quite difficult to actually read and work with here, but we do have a search tool. So we can search for build.properties. That's one of the file names. And what we can do here is we can modify the display name, for instance. We could modify any data here, but I'm just choosing to change the display name. And I'm going to insert an image tag with a XSS test script. So what would happen is if share was vulnerable to this type of attack, the code that I've put into that onError function would execute, and a potential attacker could do bad stuff with that. So that's just gone straight into the display name, and that's only one example of the sort of things you could test or debug using this interception technique. So, okay, we've made that modification. We're now going to forward that on to the client. So remember, this is the data that's come back from the server. We're intercepting it before it gets to the client. So we forward it on to the client, and now let's head back to share and see what's happened. Nothing's happened because we've closed that security hole a long time ago. But what we have got here is we've got the modified data being displayed. So what we've been able to do is we've been able to intercept that response from the server put in our own data and then have that data rendered on the client. And now, as client-side developers, that gives us enormous power over the responses we get back. So we don't anymore have to spend the time building up a complex set of test data on the server. We can just modify the data we need on the fly without changing any code in our app. So we can actually inject variables. We can do proper testing of the app during a debug thing to see how that responds in different situations. So that's a fantastic new tool that I found that I'm using quite a lot. So let's come back to PowerPoint. Okay, so there are a couple of Alfresco specific debug tools that I haven't got time to go into properly today. Surfbug's one of them. If you haven't heard about that, check out this blog. And yeah, that's really useful. It's a blog post that Mr. Draper wrote. And there's also another blog that I keep referring back to because it's got some really good tips in it. It's a little bit old, but this one Kev wrote way back in 2010. So it gives some good tips there. As I say, it's old, but it's still quite relevant. And what I'd like you to take away from this session, above anything else, is that the process you approach debugging with is what will determine the outcome of that debugging. So if you go in with the right process, the right approach, you should be able to debug any issue. And so that's everything I've got. Hopefully it's useful and you've learned some good tips. I think we've got a few minutes for some questions. I've got a question down the front here.
Hello. This is very good, thank you. One thing that I always have a challenge with is writing unit tests for the client.
Okay, yeah.
Are there any tools or what usually you do with that? Thank you.
Yeah, there's a huge range of tools that have sprung up recently. We're currently investigating tools internally within Alfresco. And there's a endless range of different frameworks. We're looking at things like Intern and Jasmine, and yeah, if you just go run a Google search for test runner frameworks, then that will give you a good starting point. We're not able to recommend a specific one because we're still doing the evaluations ourselves, but yeah, that's quite a fast-moving area at the moment. So
in the code, is there in the source code we have examples?
If you ask that question again in 6 months, I'll be able to say yes. But at the moment, no, we don't really. It's not something we've been that good at. But yeah, that's changing. Okay. Any other questions? There's one at the back there. Just making Andy run around, aren't you?
Yep. So I saw a lot of this for Share. How much of this will actually work for Alfresco Workdesk as well? Because I know that we don't have surf there, but we do still have a lot of the other interactions.
Yeah, a lot of the same debug techniques will work for Workdesk as well. So yeah, the principles, as I said at the start, you can take this and apply it to any web app or even a heating system, for example.
Thank you.
Sure. Any questions? No? Great. Well, it's lunchtime now, so go off, enjoy your lunch, and thank you for your time.